Hello, can you hear me? Hello, can you hear me?
Yes.
Yes, we can hear you, Dr. OG. What's up? Good morning.
How are you, Miss Victoria? How are you?
We're always good back here.
I can hear you.
Yeah, I was
Good morning.
how are you? I was having a hard time logging in before, but then it's working now. Yeah. So this is our last class. I know you don't have to come on Wednesday.
Yeah.
Oh,
Thank the Lord, oh my soul.
I know
Yeah.
you're excited, huh?
I am excited. Finally out of statistics.
You
Come
said you
on.
might be excited, but we still got a final exam.
Yeah,
I'm struggling with the
I'm gonna put the practice. You know the way you see homework. I'm gonna see the practice questions online. By Wednesday, it should be there, so that you can use it to practice for the final.
Okay, thank you.
Yeah, Miss Laura, you didn't send me the email. I didn't see your email. Miss Laura, there. Hello. All right, let us begin. Like I said, we have finished the curriculum, but
Dr. OG, I'm here.
okay. Yeah, you didn't send the email. The assignment you want to be open for you. I didn't see your email as of for Friday last week. I haven't seen it, so you still have time. Got a system there. All right, let's begin. Again, we have finished really. Nothing left. So I'm gonna do one example of what we did last week, another example of it, and then we are done. And then we see you again on the exam date. I'll put the exam. I'll let you know when the exam is ready, so that you can go and take it. Now, let us begin. Taking you back to let's go to the classroom first of all. Anyway, now, if you look at my announcement, you'll see that it is week 15. Yeah, I did nothing. Except apart from the classwork, there's no classwork really. This one is due. These are old assignments, right? Yeah, these are old assignments. So it's just a project. The project. This was all past due. So it's only the project that is due on the May 5th. So there's really nothing to do. No classwork, no homework. Say your project. Now, I will take you back to the question. And the question is this one here. It says, remember, this is under the topic regression and correlation. If you remember, it comes under the topic regression and correlation that we introduced last week. Yep, correlation and regression. So we did one example. We're gonna do another example to to refresh your memory on that. For regression and correlation, you can either use the formula method or you use the Excel method. We are using Excel method, so it make your life easier for you. Okay. Now, this is the one we did last week. Now let's try another type. This week we'll have this one. Let me just make sure you're seeing it. Yep, you're seeing it. Okay, good. It says the table shows mileage and prices in thousands of 8 cars in a month. And it says this is the mileage, this is the price. Mileage, both of them are in thousands. Like, for example, this one is 21.8. That means 21,800. 34 means 34,000. 16 means 16,000. Okay. And so on and so forth. It says calculate construct the scatter plot for this data. Then calculate the correlation coefficient R, compute the values of the R square, explain our results, find the regression equation, and what would the predicted price for a car with 45,000 miles be? So what would the predicted price be for a car with a 45,000 miles? And then it says here, is there any relationship between mileage and car price? Use R for 0.05. Okay, let's do it. First thing is to put this data set in Excel. Then you go from there. Okay. So I'm going to put it in Excel. I'm going to copy this from here. I know that this side is mileage and this side is for price. So I can just copy it from here. Okay. Control C. Then I go to the Excel and paste it there. I'll paste it here. And this one side is for mileage. Somebody entered here. And if I hear, okay, somebody entered now. So this side is for mileage. And this one is for price. So let me make this much bigger so you can see it better. Yeah, you can see this better now, right? Hello?
Yes.
Okay,
Yes.
good.
Yeah.
All right, very good. So mileage and price. So now it's in Excel. Now, once it is in, you can do anything you want with it. Like now, we are trying to answer all these 5 questions here. Construct the scatter plots. Calculate the correlation coefficient R. Compute R squared. Explain our results. Find the regression equation. What would the predicted price be for a car with 45,000 miles? And is there a relationship? Actually, 6 questions. So the good thing about using Excel is that it will give you the answers to all these questions at once. Save you a lot of time. Since you have enough time on your hand, you can understand it better. You can do as many examples as you want. So now to get it done in Excel, we have it. A first thing is to put the data entry part. We did it already. And this is our data entry part. Next is to Next is to start the work, the actual work. Okay. Okay. All right. Now to do that, if you have questions, please ask me. Don't do chatting. I don't chat when I'm in class. If you have questions, ask me here. Okay. Now
yeah, I look forward to observing the correlation coefficient in Excel because that just gave me some challenges.
Oh, that's what you're doing now. We're about to do it now. Hello, can you hear me?
Yeah, sounds good.
We're about to do it now, yes. So you saw how I entered it in Excel, right?
Yes.
Yeah, so now next is to do the actual work. So first to do it, just go to data. See what you can see my hand at the top, right? Can you guys? Can you see where my hand is at?
Yeah.
Yeah. You click on that. Once you click on that, you now pop out. You can see the data analysis showing on this side. If it doesn't show, I explained to you guys in the class how to put it there, to add it. So click on data analysis. Oh, before I do that, remember you must know what part is the X variable and what part is the Y. Okay. For example, S is the independent variable. That one you don't have the control over. For example, yes, we know that mileage might affect price, but you don't know the exact amount the price will be for a given mileage. Or you know that it will affect the price. So that means that makes price the Y variable and makes mileage the X. Mileage, you can decide how many miles to drive. Am I right? Am I right or wrong?
Yeah.
You can say I'm gonna drive only 5 miles today. You can control that, but the Y variable, the price that will result, you won't have no control over it. So that's what. So you have to figure out which part of these two variables is the X and Y. So price is the Y in this case, and mileage is the X. Now, so now you click on data analysis. Again, remember, click at data, then data analysis. Now, you look for regression. Scroll down and you see regression. You can see right here, regression. Click on that. Then click OK. Now you can see what you have, the input Y range. That means this is the Y right there. Now don't click on the Y, the letter Y, start from the price. We know that, see? So that's what you're gonna, don't click on the letter Y. You gotta start from the price. So you already know that the price is Y variable. So I'm gonna click here first, then start from the price all the way to the down, only on the price. Then click back here. Then for the X variable, click. Remember, don't click on the X. Don't click on the letter X. Click on the mileage that represents X. Click on that and scroll down. Okay. Now, then it asks you for labels because you clicked on the name mileage and the name price. So that means you're gonna check label. Check the labels. Now, if you want the confidence interval, it will give it to you anyway. If you like confidence, you can just click and it's already there. It's giving you 95%. And you remember that the question, when it was asking you to test hypothesis, it says at alpha 0.05. So by default, it's already 95% here. Okay? Because it says confidence level 0.95. If you want to change it, you can just click on it. Let's say that you are doing like 90%. You can click on this and change it to 90. But since we are doing 95 already, so you can just leave it at 95 and no need to click it. Yeah. But if you want to change it, you can just click and change it. Then for the output range, click on the where you have output. Output range means where you want the answer to be presented. So you can click on this. I will say, let me put the answer here. And then click on that again. Now, what else do you need? We need we don't need, I need a line of fit. That is because the question says, the very first question there was to calculate the scatter plot of this data. So that means we need the line of fit. So we're gonna check line of fit right here. Okay. And then click OK. Oh, I must have, so but as soon as I click OK, it will bring us this. See the results, give us the results. And it also give us the line of fit right here. You can bring it down, see? You can see it's trending down. So now with this, all this information that it gave you, you can now answer those questions, okay? The first question was, or is, construct a scatter plot. So solution, for the scatter plot is right here. We have it already. You can see it on that screen. It's right there. Mileage, line of fit. So you can see the orange color for the predicted price. But basically this is the S and Y. X and Y, price and mileage. This is price, this is mileage. So just click on the tip of this once time, do Control-C, then go to your Word document and paste it there. Okay. Now, after you do that, you can now expand it. So you can see it clear. Click on it once. Click here. Drag it down. So you can see the expand it very well. So you can see you can see that it is trending down. And down. See? And if you want, like, you can remove these two things. These two before you can put it. If you like, you can remove it in Excel. Now, interpretation of this. Okay. You can see that the scatter plots and make it 18. So this scatter plot indicates that it's trending down. That means it indicates a negative linear relationship between x and y variable. Excuse me. A negative, the scatter plot indicates a negative linear relationship between the mileage and price of the car, right? What does this mean? It means that as the mileage increases, the price decreases. Now, remember this guy. We know that when you want to buy a car, the higher the mileage, the lower the price. Am I right? Am I right or wrong?
Yes.
Yeah, but remember we also have exceptions. There are those cars they call antique cars, like old cars. They call it antique. I mean, people are really to pay big price for that. So that can be an exception. Miss Bird, you good? Miss Bird, can you hear me?
You calling me?
Yeah, say you are good, Miss Bird?
Yes, I'm fine.
Okay, good.
Okay.
So that means the higher the price, the lower the price, the higher the mileage, the lower the price. You can see it here. If it's the mileage is 15, if you go all the way to here, you can see that the price. Sorry, if the mileage is 100 here, see the price goes down. But the mileage is let's say 2 miles, the price goes up. You can see right there. See? So now, any question before we go to the next question? Any question on this one? No? Oh, yes. Okay, no question. Very good. The second question says, calculate. Let me make these questions to be bigger. 16. Say, calculate the correlation coefficient R. Okay. Solution. Now, that means you want to find R. Okay. We can get it directly from the okay. We can get it from the Excel. It's already there waiting for us. So you can go to the Excel. Oh, actually, it is small r. So that is small r. Okay. You go back to the Excel. You see from here, summary output. I can make summary output to be merge and center. Okay, you can see the regression statistics. Well, we have multiple R. That's your R right there. That's your R right here. Okay. So let me make them to be 2 decimal places. So I'm going to reduce the decimal places to 2. Yeah, I mean, you can even leave it at 3. It depends on what the question says. How the question, if you want it to be 3, you go back to 3 decimal places. So based on that, our R is 76.76. So our R equals 0.76.
Hey, greetings, doctor.
mhm.
So I totally forgot this hack here where it's like, you added utilizing the data analysis. And for the correlation coefficient, I tried to add it as a formula within the cells. And for some odd reason, my numbers kept being off. Like they were like whole numbers, like in the thousands or so.
Mm. Oh,
So
yeah,
I don't
but
know if you
now, how about
go
now?
ahead.
You understand it now?
Yeah, if I can just track down the data, not like the pathway to steps, yes. But yeah, I was trying to do it like into the formal formula and
Oh yeah, the formula for R. You mean the formula for R?
yeah, I saw the equation, but when I was entering it, it seemed like I don't know, like some of the steps was off. I don't know if it was like brackets. I felt like I added like the brackets to do this operation first, like thinking about please excuse my dear Aunt Sally, blah blah blah, order operations, but it
Okay.
ain't really work out.
Yeah, actually, I'm about to say something about that R part. Now, if you look at the one we have here, see the scatter plot tell us that it's trending down. That means it should be negative, right? But it didn't tell us that. It didn't tell us that it's negative here. So, but you can see from the scatter plot that it is negative because it's trending down. So, now that's why I want to show you here that this is should be negative. So otherwise, you can use the, like you said, you can use the formula. And this is the formula. I think I have it somewhere. This is the formula you're talking about. Oh, this is not it right here. Formula should be here, right here. See, that's the formula you're talking about, right?
That does not look familiar. It was another formula. It was like two
Okay.
part.
Are you using are you doing it with calculator?
No, I'm doing it. I was trying to do it in Excel. It's like some number minus another number in brackets, then minus like these two other numbers divided by.
Oh, you're using you're trying to put the formula.
Yeah, in Excel. And then
Okay.
it's like two more numbers by the standard deviation. And it didn't produce the number. It was producing whole numbers, not even like to the right of the decimal.
Yeah, formula, if you want to do it in Excel, you do it that way. You need to get more columns. Like, let me go back to that Excel. You want to do it that if you want to use the formula, that means you have to get three more columns. You're gonna get the
yeah, I did that part. That was the easy part because it's like what x times y and then x to the second power. That wasn't hard. It was actually after you get all of that information, you sum the bottoms. I got that. It was taking all of that data and putting it into the Excel,
the formula,
the last formula to produce the correlation coefficient. That was the challenge. So I'm not sure if you've done it. If you've done it, it'd be great to see that in real time.
that would be using getting the this is the formula you're talking about. I think I know the formula you're talking about now. You're talking about one of these. This is the one you're talking about here, right?
Yeah, exactly. That's it.
If you want to use the formula part, we are using Excel part. So, but if you want to do that, you can get it directly this way. You can get the numerator first. Get the numerator first. Keep it one side. Then get the denominator. Put on one side. Then you can now click on numerator, divide them on denominator.
Could you show that in Excel briefly?
Yeah, let us finish the questions. Maybe I will do it at the last.
The last component.
Yeah.
Okay. Thank you.
You're welcome. So now we have next question would be here. So the where are we? Where are we? Okay. So we did the scatter plot. Then so you know that this is negative. If you if you look at the scatter plot, it's trending down. That's tells you that it's negative. Otherwise, you can get it directly. I'll confirm it with using this formula here, which is the Courier. The Courier function, this is how it can be gotten. It says, Courier says, you can say it, I can do it by the side here. Equal Courier, I'm gonna make it capital. Courier, 1 minute. Who is this person? Tyler. Oh, who is this? Tyler. It says Tyler. Shadow Jones. Oh, Tyler. It's Tyler. Just give me 1 minute. Let me find out who this person is. Okay, I think it's Tyrese. Okay. Please, if you have any question, ask me direct here. Don't do the chat. I don't do chats when I'm in class. Put equals Courier. It will pop out. Say array 1. This is the first array. Go here. Put comma. Then array 2. Then close it and press the enter key. See, it give me the same answer here, but it will give to me as negative. See, so if you're not sure from the chart whether it's negative or positive, you can just do Courier by the side, and you get the answer. So you can now make it to the smart places. See, 17 was negative. Now we're not doing the ANOVA, so we're not using the ANOVA part of it. Now, this is when we put this here is negative 0.76. What does this means? Interpretation. Okay. So this means that this indicates. Now, remember, I will give you the chart where you can use it. I will help you to interpret this. I gave you the chart in the classroom, and that chart is right here for different values of R. Right here. You can see it from here. I'm gonna make it. So this is where our own value fall. See, it's highly moderate. See, 0.6 to 0.8. So this indicates moderate, not very high. It is high. It is high. Linear relationship between X and Y. So negative 0.76. Negative 0.76. The correlation coefficient of negative 0.76 indicates a high, I would say strong linear, moderate strong, right? Moderately strong. Let me put it this way, that would be better. Moderately strong linear relationship between mileage, which is the X, mileage is the X variable, and price. Mileage and price, Y. Okay. Any question, please ask if you have. Like I said, if you are sending a chat, I don't go to chat room when I'm teaching, okay? If you have any question, ask me now. No question? Okay, good. Good. And let's look at the third question. It says, compute the R square. Explain your result. R square is the coefficient of determination. Coefficient of determination. And that is what you call the R squared. R squared. And Excel have already given us the value for R squared. Okay? You can get it from Excel right here. You can see it right here. Okay? See R squared. You can see right there. R squared. Let me use this color for it. 0.57. So 0.57. I'll go and put it right there. 0.57. So how do we interpret this? Okay. Now, it means that mileage, I'll put it this way, about 57% of the change in price is caused by change in mileage. Generally speaking, what I was going to mean that the change in the Y variable is caused by so amount of changing in the X variable. So that means in this case, the Y variable is the price. So the R squared of this, okay, the R squared of 0.57, okay, means it means that about 57% of the, now remember in this case mileage increases, price decreases. So about 57% of the change, or if you like, you can call it the decrease, or the decrease in price of the car, okay, is caused by the change, which in this case is the increase in the mileage. What it means. Okay. Okay. Any question? I'm having my allergies. My allergies have already started. I don't know about you guys. Any questions? Good. Excellent. Since there are no questions. Then next question now says to find the regression equation. Again, the good news is that Excel have given us the what it's gonna be. Remember that the regression equation is written in this form: y equals b0 plus b1 x. Since this is a simple regression, we're doing simple regression, not we're not going to do multiple regression. Okay, what multiple regression can take a long time. At this level, we don't need it anyway. This is how the regression equation looks. The general form. Of course, you can put the error, if you like, the error margin, but we're error margin small a. But otherwise, we're estimating we're gonna be estimating all this part. We're not looking at the value of the error now. So I'm gonna remove this a. Okay. So now, from our Excel output, we can find our B0. B0 is the intercept, y-intercept. Okay. I mean, let me give you an idea what this y-intercept means. It means the price, okay, of this car when the price when X and mileage is 0. Okay. But we don't have a 0 mileage here, so we don't have, but it's mean the price when the mileage, when the S variable is 0. That's 0 mileage. So that the y-intercept. The value of the value of y when S is 0. Now for the S-intercept, B1 is the slope. Once you get these numbers, you can now plug them into this equation to get the regression equation. So from the Excel, let's go to Excel and find BO and B1. You will see where they wrote, like I said, we're not doing ANOVA, so I'm not going to go into this one. But you see where they have the coefficients. See this column, coefficient. See that? This is the slope, the intercept right here. And this is the slope as B1. So I'm going to make them two decimal places to make it more simple for us. Yep, this is it right here. Yep, Miss Bird, you raise your hand, right? Can you unmute yourself so that I can hear you? Unmute. Can you unmute, Miss Bird? Miss Bird, can you unmute yourself?
You saying Bathia or Bird?
Bird, Tyra Bird.
Oh, okay.
She raised her hand. Miss Tyra. You have to unmute, Miss Tyra, so I can hear you. You will see the unmute. What is it located on my screen? Yeah, yes. Oh, you can see it on your picture. You can see that this is for unmute. Click on it to unmute. Yep, that's it. They got it. Yeah, what's your question, Miss Tyra? I think I'm not here. Yeah, Miss Tyra, you're not muted anymore. You can say the question now. Yeah, something must be wrong with the computer you're using. Yeah. Yeah, I can't hear. I didn't hear Miss Bird. Let me see if she has it here. Okay, Miss Bird, can you put it on the chat room? Let me see if I can get it from there. Can you put your question? Because I can't hear you. I'm not even sure she can hear me. Miss Bird. Miss Bird, can you hear me? I can't hear her.
Remember how she always says in class that her
Yeah,
computer be
her
acting
computer
up?
have
Maybe it's acting up again.
Yeah, Miss Bird, can you put it in the chat room? The question in the chat room. Let me see. Since your computer I couldn't hear you from the direct. So while we wait for Miss Bird, we can continue. The intercept is 17.1. Let me write them down. My paper. The intercepts BO is, you can see, 17.10. And then the slope of B1 is negative 0.09. Okay. We have we can now go to the our question workbook and then put it here. B0 is 17.10 and the B1 is negative 0.09. So that we now plug them into this equation. We have that the regression equation is the regression equation is okay, y equals 17.10, okay, minus 0.09 x. And that's the equation right here. Okay. So let me check the chat room, see if Miss Bell have anything there. No, she didn't have it. All right. So what does this tell us? This is the slope right here. Slope, as you know from your algebra class, slope is the rate of change. So, and at the beginning of this, I explained that these are all in thousands. Like for example, 21.8 means 21,800. And this 16 means 16,000. So this one we have here is 17,100. You multiply by 1,000. You multiply this by 1,000. Let me see if I can get did I open the page for in 1 minute? Let me see if I can open the page for who's iPhone? That's iPhone. Let me open the page for calculator. Okay. In 1 minute, I want to open this page. Desmos. Okay. Now I can take you there. So if you look at this here, we got 0.09. Okay. 0.09 times 1,000. 0.09 times 1,000. $90. Okay. But since this is 2 decimal places, see, 2 decimal, and we want to make it whole number. Instead of multiplying by 1,000, we're going to multiply by, well, it doesn't matter. 1,000 is good enough, because these are in thousands. So let me not confuse you. 1,000. So this means, 0.09 means, in that case, in essence, means $90. Okay, that's what it means in essence. So having that in mind, we can say here that that the slope 0.09 means $90. So that means that the mileage, the price, the slope of 0.09, which is, like I say, is represent $90, right? Okay. It means that the price of the car, remember it is negative. So it's negative, that means it means decrease. See? It means that the price of the car decreases over time at the rate of $90 per thousand mile increase in mileage. Okay. Yeah, for 1,000 mile increase mileage. If it's 100, that means the increase at the rate of $9 per 1,000 mile increase in mileage. Okay, that is what this thing shows us. So any question on this? Yeah.
Hey, Professor, I know we're coming up on time in about 8 minutes or so. Could you demonstrate a brief run through of the correlation coefficient in Excel?
You mean to use that formula?
Yeah.
Yeah, let us finish remember, this is a class. Let's finish what we have now.
Okay.
Then I will show you there. Let me because since everybody's going to be using this Excel to make it easy, then I can still demonstrate that one as soon as we finish. Okay. We have only two left, 2 questions here left now. Okay. So let's do the E part. Say, what will be the predicted price for a car with 45,000 miles? All you gotta do is to write the equation here. Solution. So in this case, S is 45. S equals 45. So I just removed the 3 zeros, just the way I removed the 3 zeros at the beginning. So I make our X 45. We mean 45,000. So when S is 45, then Y become equals 17.10 minus 0.09 times 45. So we can put this in the calculator. Let me write this down. Y equals 17.10 minus 0.09 times 45. So I can go and get it from the calculator. So you have 17.10 minus 0.09 times 45. I mean, it's 13.05. Right now. 13.05. Okay? 13.05. Taking you down to that place. You have 13.05. Which means that the price would be 13,050. So if a car of 45,000 miles, the price will be 13,050. And you can see that from if you look at the chart, 13.05, if you look at 13 if you look at the original data, we don't have a small amount of, we don't have 13 on this side. But this gives you a rough estimate of what it's going to be, if assuming that the relationship is linear. Yeah. So that means a car with 45,000 miles, the mileage will be for the price will be $13,050. Now the last question on that section is this. It says, is there a relationship between mileage and car price? Use alpha 0.05. To answer this, write HO. We are testing for the relationship for the any relationship between the two. We're testing for rho. Let's call it the rho, which is the value of the population correlation coefficient. I'm gonna get it from here. You can write it down somewhere. Is the rho. I'm gonna get it from. Just give me 1 minute. Let me get the symbol. I have it somewhere right here. Rho. This is how it is written. Rho. Okay. Taking you down. So to answer that question, it says, is there a relationship? And if it's and it says use alpha 0.05, that means you're testing for the significance of the correlation coefficient rho. So it puts we assume that there is no relationship between the two of them. Rho equals to 0. That means x and y are not linearly related. Okay. Then the next one is the that they are linearly related, which is rho not equal to 0. Which we say is there a relationship between the two. H1 rho not equal to, I'll make it bigger. Okay. Rho, I'm gonna make this not equal to 0. I'm gonna insert the symbol here. Are linearly related. Okay. You can make this your claim that they are linearly related. This can be your claim right here. I can call it a claim. So now, or if you're assuming that they are not, then this one becomes a claim. But if you say that it's supposed that if there is any relationship between the two, you can use it as a claim. Now, say alpha 0.05. Remember, I put it at the beginning when I say confidence interval is you give all the by default 0.05. Now, the relationship between these two, you can get it from here. Let's use the p-value. Our output gave us the p-value right here. You can see the p-value right here. See? You give us the p-value for intercept and p. This is the p-value we'll be using for the mileage. See? You write this down. P-value equals 0.029 4. If you run it to for the smart places. So our p-value is that our alpha is this, and our p-value equals 0.0294. So now, if you remember the criteria for p-value, when the p-value is less than alpha, you reject null hypothesis. If you remember, if you're using the p-value method, if the p-value is less than alpha, you reject. So reject HO, okay, since the p-value of 0.0294 is less than the alpha of 0.05. Reject it. Then that means you're rejecting this, which means that they are linearly related. So remember, this is a decision here. I'm gonna put decision right there. Is to reject since our p-value is less than alpha. So the conclusion okay. So that means we are rejecting the null hypothesis. So this one is the claim is good. There is a linear relationship between X and Y. Okay. Any question before we Miss Bell, can you is it working now? Can you not yet? Okay, maybe we can put it in the chat room. So that's basically what it is. There's a linear relationship between the two variables. So now, Mr. Simba, right? You see there? Hello.
Yeah, I'm here.
Okay. Now back to what you're asking.
Excuse me, sorry, Dr. OG. I
No.
have to go. I have to drive to school for my next class.
Okay, sure.
But
Class is over anyway.
no, because I know what you're about to explain to him. So
Oh.
I have a problem with Alex. It's been cheating me again. For the test, I took a picture. I'll send you the picture. Something is wrong.
Yeah, send
I
me
know
the
I
picture.
did.
Send me the picture.
You know, like
you
what
gave
I
me.
told you in class last week, I had
Yeah.
the same problem with the test. Like I get the correct answer, but Alex is saying it's not correct. But then when it's time to move on to the next question, it gives me the answer, and the answer is exactly the same answer I was putting. I took a picture. Just
Yeah,
like
send me the picture. I will check it with the one you gave me before.
please check it. Give me my grade, because Alex is a liar.
Alex is a liar. Alex
is a big liar. I want my grade.
Yeah, send it to me. Send it to me.
Yeah, I want to send you the picture, but I have to go.
Send it with the question, okay?
No, everything. You know how it gives you the answer at the end with your answer and the Alex answer is the same thing in the question, but for some reason it said to me like didn't give me the grade for it.
Yeah, send me the picture. Send me the picture. Tell me the name of the if it's possible, because we get the question number too.
It's question number 3.
No, I mean the question number.
Question number 3, and I think it was.
No, what I'm saying is that if it's possible to include it in the picture, so I can see the question number.
Yeah, it is in the picture.
And the
Like I
assignment.
took the whole because I knew you were not gonna believe me, so I took the whole picture.
Okay,
but
good.
yeah, question number 3, part 3.
Yeah, just let me see it on the picture, then I'll take it from there.
All right, thank you. It was great doing business with you. I am glad I'm getting out of statistics. And I hope by the time we do the exam, I can
No
pass
problem.
with at least a B.
No
Please
problem.
don't give
I'll
me a
see.
C.
I'll see. I have no comment on that until everything is
I do
everything you
not
do.
want my GPA score to drop because of you.
Your grade is there, so everything when I put everything in, it will tell me what your grade would be. You know. Yeah,
All right, bye everybody. I wish you good luck in the exam, okay?
I'm sure, no problem. Oh,
Okay,
Miss
bye.
Christina, before you leave,
Uh-huh.
I know I said that there's no point. Well, there's no point coming on Wednesday. We are finished. So go ahead. Go ahead.
Yay!
So now let me show Mr. Simba. Those of you who wants to stay, you can stay and watch. He want me to use this formula. What's the formula right here? He want me to use. So let me write the formula down, and then we can go and can I put it in Excel? Let me see if I can put it in Excel so I can see it better. If I can, then I'll write it down. Let me see. KFC, enter here. You won't enter here, okay?
Don't forget, you might want, if you got that previous Excel sheet, you might want to add it there so you don't got like adding all the other numbers again. But
No, I have the numbers. So I just want to make sure, see if I can put the formula in.
all right.
Let me see if I can put it in a text box. Allow me to put a text box. Okay. Okay. This way I can put it in a text box. If it doesn't go in there, then I'll just write it down. It won't let me put it. So I'm gonna write it down on paper. On my paper. So this is if you want to use, this is one of the formulas we use. Is R equals N summation XY minus summation X times summation Y over the square root of, we got, this one is N times summation X squared. Okay. Okay, minus summation X squared. Okay, times N summation X squared, summation Y squared, minus summation Y squared. Okay, let me write it down. N times summation Y squared minus summation Y. Okay, good. So now what you're gonna do to use this formula. So now, class, this one is not, I'm just showing him something. So you're not gonna use this method, okay? So I'm gonna copy this question down here, first of all. Copy this. And then paste it here. Okay, so to use that formula, this is your mileage is your X, and price is your Y. So we need to get X times Y. X times Y. You need X squared. You need Y squared. Y squared. What is the cap key? Okay. Now for X times Y, that means this times that equals this times that. Once you do the first one, you can just copy this down. You calculate the rest of them. Do the same thing here. Here we're gonna square it. So equals, put parentheses. For X, click on X, close the parentheses, then raise to the power 2. Then press the enter key. Then, of course, double click on it to get the rest. Then for Y square equals, click on Y, close the parentheses, and then put the square. Let's raise to the power 2. Then double click, or you can either double click or you can drag it to get the rest. Then you get their totals here. Total for all of them. Okay. Now I'm gonna put all these things in. Okay. Look at the totals. Oh, you know what? Total should gonna be outside here. Total.
Yeah.
Total.
And then you can just go down at the sum form.
So it equals sum. It pops out. Double click and highlight this. Press the enter key. I like to close the parentheses. Press the enter key. Give me this. And then I can just calculate all of them. Just go from here and just drag it down to get the rest. Okay. You have your totals. Now, since you're using this formula here, you're gonna write them. This one, there is n times sum of xy. So you write it down here. We have n so small, n times sum of x, sum of, I cannot put the character here. Let me see if I can put the character. Let me see if I can put it from here, if it's possible. Yeah, I can't put the character. It won't let me. So I'm just gonna write it times sum of x squared. This is sum of x squared right here. Sum of x squared. Sum of x squared. X squared. It is right here. X n times sum of x squared. And I mean, 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6, 7, 8. N is 8. So it'll be 8 times sum of x squared is right here. Okay. The next part of the formula is, I mean, you have to separate the formulas, kind of dissect them. Sum of x. Oh, you know what? Yeah, I want to do n times sum of xy. My mistake. N times sum of xy. So you're gonna have 8. 8 times this sum of xy right here. Okay. The next will be n sum of xy, sum of x times sum of y. Okay. So sum x times sum y, which is just by being saying this this is sum of x right here, sum of xy, because that's what it says, sum of x. But he's saying according to what he's saying on the formula, he says sum of x times sum of y. So you can just put it right here. Sum of x is right here times sum of y. Got this number here. So next will be this part of the formula. We have n times sum of x squared. Okay. We have n times sum of x squared. So you go n times sum of x squared, sum of x, excuse me, sum of sum x squared. X squared. So you have n times sum of x squared. It means 8. This is 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. 8 times sum of x squared is right here. Right here. So this is the sum right there. Okay. Now we get sum of x squared. Then we have sum of x squared itself. Sum of x squared. I mean sum of x squared. Okay. All right, sum of x squared. We have sum of x, sum of x squared. Equal, this is the sum of x. You gotta square it. So you have this squared. Square, that will give us this number. Then we're gonna get next thing will be okay. Next thing will be, we'll repeat the same thing for y. N times sum of y squared. Okay. So I'm taking, you take the formulas apart, then combine them. N times sum of y squared. So you have n times sum of y squared. Okay. Okay. N times sum of y squared will equal, n is 8. 8 times sum of y squared. I think a better way is to put the formula in and then get, I think I know the best way to do this. Anyway, let's finish this one. N times sum of y squared. This is sum of y squared right here. Okay. Enter. Then next is sum of y squared. Okay. Sum of y squared. Sum of y of y squared. Okay. Gives you equals, this is sum of y right here, of y squared. So I have taken the formula apart. Yeah. So we have I want us to be looking at it while we put it together. So now that means our regression coefficient now becomes let us get the numerator part of it. Numerator equals numerator says, it says n times sum of xy minus sum of sy times sum of y. So n times sum of sy, let me n times sum of sy minus sum of s times sum of y. So numerator will now becomes, I'm looking at it on my paper, n times sum of xy. You can see right here. N times sum of xy is right here. You go at this. Oh, excuse me, my mistake. Equal sign, then parentheses. N times sum of sy, which is this. Okay. Minus sum of x. Sum of x, say sum of s times sum of y right here. In parentheses. That gives us this number, negative. Okay. Then let's get the denominator. Now the denominator says, it says here, square root of n times this. So let us get this part first before we can get the square root of that, or we can get it directly. Okay, let's see. We have let's try the first method, see if it doesn't work, then we'll try the second method. If you're doing on board with a calculator, it's much easier. Just put the numbers into the formula and get the answer. So square root of equals SQRT of n times, okay, n times sum of x squared. Okay, n times sum of x squared right here, minus sum of x squared, close the parentheses, okay, times n times sum of y squared, okay, minus sum of y squared. Close it. I'll give you the denominator. Okay. Give this answer right here. Miss Simba, you see there?
Yeah, I'm here. I'm following you. It
Okay.
wasn't until like the second power or something.
Say it again.
It wasn't until like the second power or something like that. That was in the denominator component.
Right here. Square root of, see what it says? It says square root of this. Square root of the whole of this.
Yeah,
Okay.
but it's x to the
Say the
ex
square.
to the second power.
Remember, we get all this part separate.
Oh, separate. I got you. I got you. I got you.
So I'm combining them now. See?
Right,
So
yeah,
I got the numerator part of it. Now I got the denominator to be this.
Mm-hmm.
So now the R now become just the numerator divided by the numerator divided by the denominator. This by that. See? The same thing, 0.75.
Yeah, I got you. I
Yeah.
think for me, I think my approach was a little different.
No,
And
I think what you did, you are putting them all together at once.
yeah, and one Excel, and for
Yeah.
some
So
reason it
just
wasn't.
get this say look.
Separate them. You got to isolate them for.
Yeah, get this one separate, get this one separate, get this part separate, get this part separate, and then combine them, and you
At
get
the
your
end.
result. You can see that we see the same answer we got before. If I make
Yeah.
it two decimal places, see 0.76, and you can
Yeah,
see
I got you.
that's the same thing that we have here. See?
Yeah. That's true.
So I couldn't put them as symbols here, so I just write them out as
Yeah, no, I get you. I get you.
Mm.
Could you upload this for us to review this particular Excel sheet?
This Excel sheet here? Sure.
Yeah, that would be a helpful resource.
Let me save it. Let me save it. Yeah. Okay. Yeah. Regression. I'm gonna name it the regression Monday. Okay. Class session. Class session. I'll just call it regression and correlation. Regression and correlation. Okay, Monday. Yeah, right there. See, that's it. Okay, and then yeah, I'm gonna upload the spreadsheet. I'm gonna call it spreadsheet. Excel spreadsheet. Anybody have question for me before we leave? Because we have finished. We finished a long time ago. I was just showing Miss Simba something. All right, guys. I'm gonna, like I said, I'm gonna prepare the practice for the exam by Wednesday. Put it in the canvas for you, just like I put a homework, and then you can use it to prepare for the exam. Okay.
Yes, sir.
All right, you guys have a nice day.
We don't have class Wednesday, correct?
No, are you disappointed?
Yes.
Is that who is saying this though?
Victoria.
Victoria. Oh my. We are disappointed. Sorry about that, Miss Victoria.
Okay, well, thank you so much for clarifying.
Oh, sure. You're welcome. You're welcome. Have a good day.
Have a good day,
Oh,
everyone.
sir.
Yeah. Mr.
Sir?
This is Tyrese, right?
Yeah, this is Tyrese. I was saying the Tyler is Tyrese.
Sure. Go ahead.
No, I was saying that I'm Tyrese.
Okay, I thought you had a question for me.
No.
Oh, okay. I got your name
But I
already.
think
Got your name already.
Huh?
I got your name checked in the attendance already, so you're good.
Okay.
Maxine. You sleeping? Miss Maxine? Tyrese, are you in the class?
Yeah, huh?
Are you in the classroom at the college?
I'm in the library.
The library, okay, okay.
I have a question.
Yeah, go ahead.
See, you remember that time I came to you and I told you that I just missed 1 point on one of the classwork assignments. I missed 1 point and I got it wrong, and so I got 60% on the assignment.
Yeah, I thought I gave you makeup work already.
No, not about that. See, you remember the time you said that we have like the extra credit or something that we did in class, the question.
The time I said if you have this question correct, I will give you choose one classwork to fix. Is that the one?
Yeah.
Yes, okay. What about it though?
Huh?
There's one that I'm trying to figure out the one you are referring to. Is it there's a particular day I say if you got this question correct, you can choose one classwork assignment that I can just boost your grade. Is that the one?
Oh, I can choose one as classwork assignment?
No, I'm trying to understand the equation.
Oh, could I have the extra credit towards that assignment that I got 60% on?
I'm trying, Theresa, I'm not really understanding you. Can you ask me the question again?
See, remember that time we got the extra credit opportunity where we had to answer the question right and then had the paper into you, right? And
Yes.
then put a number on it. I really didn't have anyone and I really didn't have any classwork that I wanted to really update my grades on. But now I do. So I would like to, I was asking if that's
No,
still
that one has
possible.
passed. That one was then. It has passed. Now you can't just wake up one day. It was then. That time you told me that you don't have any classwork to update. So that one is an old. I'm not. That is like a century ago, Mr. Tyrese.
I was just trying to stick my way into getting that off my
Yeah, that
thing,
was
but okay.
even at that time. I have a time frame. I say you have to get it right so and so by this time. To
That's okay. I understand.
yeah.
All right, thank you.
You're welcome. All right, guys. Have a nice day.
Take care and be well, Professor.
I will try. You too, Mr. Simba.
Greetings. Ciao.
All right.